So those are the data exported. Let's have a look at how we can make use of those data in some other applications. So we'll open MATLAB, and here you can see I've similarly navigated through the Windows folder structure to the folder where I saved it. So this one is here, my OneDrive. I can find this folder here. And when I've got to this folder here, I've added it to the path. You'll remember that we can either add or remove folders to the path. Okay, you can see that it's ungrayed out when I highlight it. So all of these files within this and subsequent subfolders could be read by either a live script or a script that I might be running in MATLAB. Here's my folder, and here's this MATLAB data file that I previously exported. And you can see the channels are immediately recognized by MATLAB because it's in a .mat file format. There's the text file. If I click that, there's no preview available. If I double click this one, it automatically executes the load command. And here are my various variables now for the 3 channels within the workspace. If I double click this one, it'll open the variables editor here. And I can then drill into these variables to understand what data I have in here. The way that it exports these is in a structure format for MATLAB. So the X values are actually stored separately to the Y values, as you can see here. If I double click here, you can see it's opening. It's essentially drilling in like you would with Windows Explorer. Here you can see the start value. This is in seconds. And here you can see the increment. Be careful. These values are only showed to 4 decimal places. This is rounded up from 0.00195. It's the reciprocal of a 512 hertz. So 1 over 512 hertz, which is a sample frequency, is the increment in time data. But MATLAB here only shows them in this reduced length format. Similarly, I can drill into the Y values. And in this case, you can see all of my Y values at different values in time. The difference with the X values, of course, is that it's fixed sample acquisition. And we'll talk about this more in the future. But basically, all I need to be able to recreate a time array is a start value and an increment between these samples. This will become a bit clearer what I'm talking about when we look at the text file. But remember, this one we need to be careful of. Let's load this value into another value here, and you can see the workspace, this truncated format. But let's have a look at what happens when I try to report this to the screen. So I'm now in that folder. I can hit _ldv.y values.increment, and this will return this value to the screen if I've spelt it correctly. Sorry, it's okay, I'll just hit the up arrow. It's actually, obviously it's the X values, right? So there you can see 0.002, same thing. However, I should look at this in format long. If I change to format long, and if you do a help format, you'll understand what help format means. If I change from short scaled fixed point format with 5 digits, scaled fixed point format with 15 digits, now if I hit the up arrow twice and represent it 3 times and represent that value, now you can see the full resolution of that value. This value is 1 over 512. And if I do 1 over the answer, which is the increment in time steps, you can see 512 is the sample frequency. So I hope that's giving you some insights as to how the structures works with the MATLAB export from Siemens Simcenter. If we now go to the other file that we exported, the text file, and we can use a number of tools to open a text file, but Excel is a useful one, a powerful one. Let's go File, Open, and it's in my previous files that I've previously opened, but we can browse through to that folder and find that file. Here it is eventually. Oops. Right, it's not here right now because it's just looking for Excel files. We make this all files. You can see now it can see the text file as well as the map file that we've just had a look at, but here's the text file. Okay, when we open this type of file, it's going to ask us to give it some help importing this kind of file. You can see that there are lots of information in here, header data, as well as numbers, values for these 3 channels at fixed increments in time. I'll hit the next value. It recognizes the fact that these are tab separated values. Okay, so in some cases, comma separated variables might be used. We've heard of a CSV file, that's comma separated variables. In this case, Simcenter, when it exports to a text file, uses tabs to separate the values. And so you can see now columns of values separated by lines as we would expect them to be. Let's hit finish and see what it looks like in Excel. So here you go. Here are some values. Let's highlight everything and double click this here, and this will automatically set the column width so that we can read all of the information within here. You can see the time at which the data was collected, many other pieces of information, including the measured quantity. This is the LDV channel. Here's the name, and the name comes up several times. It's time, data, function, class. There's no millimeters per second compensation. Here's the range, max values. These are properties from the acquisition system itself. There's a unit, again, the quantity, velocity, quantity, G. So there's some redundancy in these data, but here you can see the sample frequency. You can see the x-axis increment. Importantly, here you get it in full resolution, and you can see the start and end time for the x-axis. So you have all of the information that we've previously seen within the MATLAB file, but we don't necessarily have that problem with this value being truncated. Here, however, you can see that this is presently being displayed in Excel in scientific units. Personally, what I prefer to do is highlight all of the data and make it display this in general format. Now you get to see, again, the x-axis unit. This is the seconds. So this is 0.048868, as you can see. Add one delta t, another delta t. These are fixed increments in time. And we have many, many of these values all the way down to the end of 40 seconds of data. If you want to have a look at confirming that these are fixed increment samples, we can just insert a column here. And let's say this equals this, 1 minus here, and that's, again, the same value that we have here, okay? Double click this one and you should see that that value is the same because these are fixed increments in time. Here's the x-axis. These are the x-axis values. These are the y-axis values for the LDV, for one of the accelerometers and for the other accelerometers. Let's have a look at what happens when we plot these values on an XY scatter, just to confirm what they look like. Do they look as we expect them? So we'll take an XY scatter. We can plot this value, these values. We can move the chart to a new chart. We'll call it, we'll give it the same name, AF 100-10. We can't use forward slashes, so we'll use dashes here. So we move that one here, then we can right click, select the data, and we can edit the series to take actually all of the values, perhaps up to, let's say, 1 second or 2 seconds, maybe we should take 1026 values because that will be 2 seconds of data. So 10, it's just a little bit less than 1000 seconds of data because obviously there's some header data in here. So, but we'll get almost 2 seconds of data if I type 1026. Have to do that for both the X and the Y axis. And I've done something wrong. Let's try that again. There are other ways to do this, of course, but this is one way. That's more like it. So there you can see we have approximately 2 seconds of data. They look similar to those that we displayed in Simcenter. We can zoom in a little bit using the axis. That's the end of this video. I hope it's been useful. I know it's a little bit long. I try not to make videos that are too long, but hopefully it's been very instructive. Thank you.